In this video, I will talk about natural logarithm. Probably you have heard about the logarithmic functions and anti-log and so on. If you are a mathematician, then to define a logarithmic function is a very difficult task. But if you are other than mathematician, like engineer or physicist, then this is very simple question. The answer of that question is natural logarithm is natural log of x. But for mathematician, it is a difficult task to define the logarithmic function, natural logarithmic function. So we define natural logarithmic function like this. Natural log of x is equal to 1 to x 1 over t dt, where x is greater than 0. So you can see that the logarithmic function should be written for some formula. It is written like this. Now the question is why we write natural log of x in terms of this expression. For that, we need to understand the graphs. The question that we are raising over here is this 1 over t can be, why not it is sine t, why not it is cos t, why there is only 1 over t? That's the question that we ask over here. So let me just draw a graph for you over here. Suppose we have x and y axis, and we decided to put 1 over t in the integrand. So I graph that function, and you know that this graph look like this. Since we are taking a positive value, there could have been another branch of that if x would have been a negative value. But this is not the case over here. X is only positive. Okay, let me just see some properties of this definition. Not the properties maybe, I just want to find out the values of x where it has different answers. The first thing we notice that when I put x is equal to 1 over here, then natural log of 1 is equal to 1 to 1, and 1 over t dt is equal to 0. So it means that this is 0. So from 1 over t, we can say that the graph of function, there will be x is equal to 1 somewhere on x-axis where the value of that graph is 0. At 1, the value is 0. So the function is passing through x-axis. Okay, this is first property, first value. Now, if x is, suppose the x is 0 to 1. If x is 0 to 1, it means that we already decided one point over here, which is 1, and we want to put the value of x 0 to 1. Suppose the x is 0 to 1. Then what is the answer of that integral? So the answer is, for x 0 to 1, we have natural log of x is equal to 1 to x. That's how we defined it. 1 over t dt. And we can write minus, since x lies over here is 0 to 1. So we can write minus x to 1, 1 over t dt. So the natural log of x has a negative area. Let me just draw it for you. Why this is negative area? Since this function lies all over the positive side. All the areas, for example, this area from 1 to, for example, x, 1 to x, it has positive answer. But the answer from x 0 to 1, the natural, this is the area, but the natural log of x is negative over there. Okay, let me just draw that function for you, natural log of x. Natural log of x will be written like this, will be graph like this. Y is equal to natural log of x. Y is equal to natural log of x. So this is the graph of natural log of x. Let me just explain again what was going on with respect to the area. You understand that from previous lectures, and you already know that when we have a to b f of x dx, then this is called area under the curve. Area under the curve. And here, this is the area under the curve. And which curve is there? 1 over t. So the curve has 1 over t has area 0 when we take x is equal to 1. So it means that we have x is equal to 1 over here. When we take the values from x 0 to 1, then the area you can see that is negative, since this quantity is positive. Okay, and when it is multiplied with negative, so the area is negative. It means that the natural log of x is going towards the negative y-axis, That's why the area is negative. Okay, so from 1 to x, 1 to x, 1 to x, the area is positive, and from when x is over here, 0 to 1, some value over here, then the area is, for example, the answer for natural log of x is negative. This area, the area of natural log of x will be negative, since it is, we say that if we just, for example, for example, remove this curve, and we say that when x was 1, the answer is 0, and the area is positive, so the natural log of x is look like this. When the area is negative of natural log, then it should move towards the negative x-axis so that you get the negative area. And this quantity over here is x to 1, 1 over t dt. When we multiply this with negative, so it means that it is over here and the graph should go on the y-axis. That's why natural log of x cuts at 1 and then it moves towards the y-axis. I hope you got the point. So from this definition, we developed a function y is equal to natural log of x that has positive area and that has negative area over here. Okay, so that's how we define uh, the natural logarithmic function. This is the definition. All the other definition, for example, if you see hypergeometric functions, gamma functions, error functions, so on and so forth. This is the whole theory in mathematical analysis where you need to define such functions. That's what we did over here. Okay, so we can formally write the definition of natural logarithm, and also we can define the exponential function as well. The number, so the definition is the number e is written as, is defined as, in simple terms, it is natural log of, when you put x is equal to e, then 1 to e 1 over t dt, then the answer is equal to 1. Okay, so the natural log of e is equal to 1. Okay, this is the definition of exponential function. Let me just move to some other examples where I want to calculate the derivative. So the idea is first to define a function, and then apply derivative or find the derivative. This is the next step. So first we find function, then we find derivative. So let me just define a derivative of natural log of x. Example, since we already saw that the natural log of x is defined as natural log of x is equal to natural log of x is equal to 1 to x1 over t dt. When you take a derivative of with respect to x, natural log of x, you apply Leibniz rule over here, 1 to x1 over t dt, and Leibniz rule says that you put the value of x in the integrand d by dx. So when you put that value over here, then we get 1 over x. That is the derivative of natural log of x. So I write it formally, d by dx 1 over x is equal to d by dx 1 over x, and by Leibniz rule says that, I maybe repeat it for you, when you take a derivative of any integrand, so first you apply upper limit minus, then you apply lower limit, which is 1, then you replace the function with 1 over x, the upper limit. Okay, that's how we define the Leibniz rule. So the answer is 1 over x. So, sorry, it should be natural log of x. The derivative we are finding is the derivative of natural log of x. If you want to apply the chain rule, then you can also do that. From this, we can also construct initial value problem. For example, the initial value problem is dy by dx is equal to 1 over x, y of 1 is equal to 0. That's how you can create a initial value problem. How you do that? For example, if we have y is equal to natural log of x, differentiate that dy by dx will be equal to 1 over x, and if you apply y of 1 is equal to 0, then you can solve this problem and you will get the same natural log of x. For example, if I just take integration, we get y is equal to 1 over x dx plus constant of integration y natural log of x plus c. When y is 0, natural log of 1 is 0, then c is 0. So we get y is equal to natural log of x. So from y to you can generate initial value problem, and from initial value problem you can find the function y. So this was the derivative of natural log. If we have, for example, d by dx and natural log of 2 of x, the derivative will be 1 by 2x d by dx 2x. Okay, so we are applying the chain rule over here, and the answer is 1 over x, and x is greater than 0. Okay, if we have, for example, natural log of x square plus 3, then according to the definition of derivative, that will be 1 over x square plus 3 d by dx x square plus 3 by the chain rule, and we have 2x and x square plus 3. That is the answer. We are solving different examples. If you see another example, suppose we have to find the derivative of u is equal to x. If we just define a variable u for x mod, and if we differentiate natural log of x mod, that will be equal to natural log of u. Then we have 1 over u and x over x mod. Since you need to apply the chain rule over here, that will be 1 over u and du by dx. 1 over u and u is x mod, and we know that the derivative of x mod is x over x mod. Okay, so we also have u defined as x mod. So we have x over x mod over here. This becomes 1 over x square, since x mod is defined as x square under root. And when you also take x mod is equal to x square under root and multiply these together, you get x square. So that's the value of x square over here. And from here, we can say that 1 over x. So the derivative of natural log of x mod is 1 over x. Okay, that was the topic of this video, where we have defined natural log of x, where we constructed this natural logarithmic function from the definition of uh, definite integral defined from 1 to x for the function 1 over t. Thank you for watching.